Today we are going to be talking about the distance formula. First, I want you to write down the formula in your packets. Now, it looks super intimidating, which it is pretty intimidating. It's actually pretty easy to do once you get the hang of it. But make sure you write it down exactly as shown. Don't forget a minus sign. Don't forget a squared sign. Make sure you get all your X's and Y's in the right spot. One thing that you need to remember that if you are finding the distance of something, your answer is always positive. Okay, when we talk about distance in our real lives, we're always talking about it in a positive sense, like I'm going to go run a mile in gym class. My house is 10 miles away. I need to walk 3 miles to school every day. All of those instances that I just gave were positive. Okay. I don't say, oh, I'm negative 5 miles away from my house. Okay. You always say, I'm 5 miles away from my house. Okay. You always talk about it in terms of positive. Now, I say that because you should never have a negative answer when you're finding distance. Okay, so always double check that your final answer is positive. Okay, because if you do end up with a negative, you did something wrong. So, our first example, okay, we have 2 points. Okay, now I could go and plot these points on a graph. So, I could go and plot 1, 4, and 4, 0, and find the distance between those 2 points using Pythagorean theorem, finding rise over run. Okay, I could go and do that. Okay, first, I don't always have graph paper. Okay, and this is algebra class. So hopefully the distance formula will help you a little bit. First thing you need to do, just like when we use the slope formula, we always label our points x1, y1, x2, y2. Okay, so always start by labeling those points first, okay, your first coordinate and your second coordinate. Okay, then from there, it should be pretty simple to just plug in your numbers into the correct spot in the formula. Okay, so here I kind of made an outline for myself, okay, so that I just have to plug in my X's and Y's. Okay, so I look first, my x2. My x2 is 4, so I'm going to start by putting 4 in. My x1 is 1, so I put a 1 there. Then my y2 is 0, and my y1 was 4. Okay, from this point, okay, it's orders of operation. Okay, so doing PEMDAS. Orders of operations from here. Okay, parentheses. 4 minus 1 and 0 minus 4. So now we're going to rewrite this as 3 squared and negative 4 squared. Okay, some people are probably going to be like, Mrs. Schmidt, you didn't get rid of the parentheses. Okay, I keep those in because notice that the 4 ended up being negative, and I want to make sure to show that that negative is included here with the 4. Okay, after parentheses come exponents. Okay, so 3 squared, 3 times 3 is 9. Plug negative 4 squared into your calculator with parentheses, like I did. Okay, so negative 4 times a negative 4 is a positive 16. Okay, if you got a negative 16 in your calculator, you didn't put parentheses around it. You need to show that you're multiplying a negative by a negative. Okay, so at this point, you should have both positive. Both of these numbers should be positive at this point. Okay, I talked earlier that our answer always has to be positive. Okay, well, at this point in your problem, this part should also always be positive. Okay, when you square something, whether it's a positive 3 or a negative 4, they always should come out positive. Okay, so after that, we don't have any multiplication or division. Okay, so now I move on to my addition and subtraction. Okay, so I'm going to do 9 plus 16, so I get 25. And then the square root comes last. So my distance between those 2 points is 5 units. Next problem. Okay, next problem, I have 4, 7, and 5, 5. So just like the last problem, the first thing you should do is label your points. X1, Y1, X2, Y2. If you remember, I kind of did a little layout outline for my problem. Okay, if you like doing that too. Okay, sometimes you just have to extend that square root because it gets a little long. Okay, and then we start by doing 5, okay, because my x2 was 5, minus my x1, which is 4. Okay, so notice I'm just subtracting my x's, and now I'm subtracting my y's. Okay, so I have 5 minus 7. Okay, it's orders of operations now at this point. Okay, so we get 5 minus 4 is 1. I still have to square it. 5 minus 7 is negative 2. Okay, so again, I do those parentheses there to show that the negative or the positive is also being raised to the power of 2. Okay, so when I put that in my calculator, 1 times 1 is just 1. Negative 2 times negative 2 is 4. Okay, so again, at this point, you should have positive answers. Okay, so you should be adding 5 or 4 plus 1 together to get 5. Okay, your last step is doing that square root. Okay, so my distance is approximately 2.24. I rounded to the nearest hundredth. Okay, so 2.24 is the approximation for the distance between these 2 points. And the last one that I'm going to go through on this video, okay, again, label your points, x1, y1, x2, y2. Okay, start by plugging in those numbers into the right spot. Okay, if you want to pause the video and try and do it by yourself first, okay, that would be a good idea, and then you can check it with me. Okay, so you can pause it right now if you want to try it on your own. Okay, so I'm going to continue. We should have 5 minus negative 3. So notice that I have the minus sign from the equation, and then I also brought the negative 3 from the point. So it's minus and negative. Okay, and that's okay. We know how to do that. Plus, you have a calculator. So we have 2 minus 4 then for the other side. Okay, doing the subtraction part first. 5 minus a negative 3 is just like saying 5 plus 3. So you get 8 under there. And then 2 minus 4 is negative 2. Again, you have a calculator, so you should be checking that in your calculator. We get 64, 8 times 8. And then negative 2 times negative 2 is a positive 4. Add those two together, we get 68. Okay, and the square root of 68, we know will be between 8 and 9. Okay, it ends up being 8.25 approximately, okay, because that's a rounded answer.